Okay, so here in this class we will discuss about full adder. Now what is full adder? Full adder is a device that is used for arithmetic addition. Now what is the difference between full adder and half adder? Suppose I am considering a block diagram and I have called this block diagram as full adder. So in full adder there are three inputs A, B and C. Accordingly, we will get two outputs. One is represented as sum and another one represented as Cout because we already consider C as an input. That's why. Okay, so full adder is a device that is used for arithmetic addition, and in this time there are three different inputs and accordingly we will get three outputs. Accordingly we will get two outputs. One is sum and another one is carry. Okay, now to analyze the whole behavior of this full adder, we make a table. We already discussed that if any table is responsible to find out the output on the basis of different combinations of input, then this type of table is known as truth table. So here I am consider a truth table in which three inputs are there, A, B, C, and accordingly two outputs are there. Okay, so because of these three inputs there are 8 different combinations starting from 0 0 0, then 0 0 1, third 0 1 0, fourth 0 1 1, then 1 0 0, 1 0 1, 1 1 0, and the last one is 1 1 1. Okay, so these are eight different input combinations. So when we here I am considering the first combination. In the first combination all three bits are 0, so sum equals to 0 and carry is also equals to 0. But when I am considering the second combination, at that time sum is equal to 1 and carry is 0. Same is reflected in the third case, sum is 1 and carry is 0. But in fourth case, sum is 0 and the carry is 1. In the fifth case, sum is 1 and the carry is 0. Why? Because when we add 1 plus 0 we get 1. When we again add 1 plus 0, then we get sum equals to 1 and carry equals to 0. Here in the sixth case we get 0 1, in the seventh case we again get 0 1, and in the eighth case we will get sum equals to 1 and carry equals to 1. Okay, now on the basis of this truth table I am calculating the output equation. So how can we calculate the output equation? To calculate the output equation for sum, I am checking the sum column and find out how many ones are there. 1, 2, 3 and 4 ones are there. So I am taking the corresponding input combination with respect to this one. Okay, so with this one the input combination is A bar B bar C. So I am taking this combination, I am writing this combination here, A bar B bar C. Second one is A bar B C bar, A bar B C bar. Third combination is A B bar C bar. Third combination is A B bar C bar, and the last one is A B C, and the last combination is A B C. Okay, now if I am taking a common part of first mean term and the last mean term, so what is common in these? So here C is common, so what we will get? We will get A bar B bar from first mean term and AB from the last mean term. And in the second and third, C bar is a common part, so what we will get? We will get A B bar plus A bar B. Okay, now this one is the output of X NOR gate. and this one is the X NOR gate, and this one is the output of X OR gate. And X NOR gate is nothing but a complement of X OR gate. Okay, so we can write this X NOR output as complement of X OR output, X OR gate. So what we can write here? We can write here A B bar plus A bar B whole complement. Okay, then we have right here C bar, and same as we can write here A B bar plus A bar B. Is it fine? Now assume, now I am assuming A B bar plus A bar B equals to P. I am considering P. So what we can write here? We can write here C P bar plus C bar P. It means that what we can write it, we can write it as C XOR P. Okay, now I am considering this one as equation number 1. So by using equation number 1, we can write the sum equation as C XOR A XOR B. Okay, now we can also write this equation as A XOR B XOR C. So this one is the final, this one is the final expression of sum. Okay, this one is the final expression for sum. Now what we now we calculate the equation for carry. So to calculate the equation for carry, we are taking the carry column and find out where one is coming. So here first one is coming, second one, third one, and the fourth one. So we can write its corresponding input combination. So what we can write here? We can write here A bar BC. Okay, A bar BC. Okay, now A B bar C, A B bar C. This one A B C bar, and the last one is ABC. Last one is ABC. So we can take C as a common element. So when we are taking C as a common element from first and second mean-term, so what we can write here? We can write here A XOR B. And when we are taking AB as a common element, that what we will get? We will get C plus C bar inside the bracket. And we know that C plus C bar equals to 1. C plus C bar equals to 1. So output C out. Okay, so what we will get? C out equals to, we will get C out equals to A XOR B multiplied with C plus AB. So this one is the final expression. This one is the final expression of, this one is the final expression for carry. Okay, so we have calculated both equations, sum and carry. Now on the basis of these sum and carry equation, we are drawing the logical diagram. So our next heading is logical representation. Our next heading is logical representation. Our next heading is logical representation. Logical representation. So we have calculated S equals to, sum equals to A XOR B XOR C, and carry C out equals to AB plus C A XOR B. Okay, so these are our two equations. So here first we draw the equation for first we draw the logical diagram for sum. So To find out the logical diagram for sum, first we find out A XOR B. So here I am taking a XOR gate whose one input is A and another input is B. Okay, this one is its output, and here I am taking a third. This one is the diagram. So this one is the logical representation of sum. Now to calculate AB. To calculate AB, I am drawing a AND gate here, and I am drawing a A gate here, and yes. So from this port we are getting AB. Okay. Now we need A XOR B. A XOR B we will get from this end. Okay. So what we have to do, we just need one more AND gate, and from this end we will get A XOR B, and from this end we will get C. Now these two inputs are provided in the OR gate to calculate the Cout. So this one is our final expression. This one is our final expression of, this one is our final representation of the full adder. Okay. I hope you understand this full adder very well. Thank you so much.